This final pour is the culmination of a recovery process that has relied on a single chemical workhorse for over a century. But because sodium cyanide is highly toxic, a global wave of environmental regulations is now forcing processing plants to eliminate it entirely. For plant operators, the challenge is immediate. There is no universal replacement that functions exactly like cyanide for every type of gold ore. Choosing an incompatible alternative risks millions in physical assets. The wrong chemical can corrode these massive steel tanks, waste operating capital, or leave the gold trapped in the tailings. To find a viable path forward, operators must evaluate 4 primary non-cyanide candidates: Thiourea, Thiosulfate, Halogens, and JIN CHAN. We will evaluate these options across 3 critical dimensions: their specific operational requirements, their extraction advantages, and the hidden trade-offs inherent in their use. Successful gold extraction requires matching a chemical's distinct properties to the mineral composition of your ore and your plant's available budget. Our first candidate, Thiourea, is a high-speed option specifically engineered for acidic processing environments. Thiourea is demanding, requiring a medium with a pH below 1.5 and an iron 3 oxidant. If met, it leaches rapidly with excellent selectivity for anode mud. However, it decomposes quickly, driving up consumption costs, and the acidic environment is exceptionally corrosive to standard equipment. The second candidate, Thiosulfate, serves a different niche. It is the primary solution for refractory ores that standard chemicals can't touch. Thiosulfate requires precise environmental control. You must maintain temperatures between 50 and 60 degrees Celsius while managing a complex mix of ammonia, copper, and sulfite stabilizers. These refractory ores often contain copper, arsenic, or antimony, elements that block traditional recovery. Thiosulfate bypasses these minerals to achieve peak recovery in roughly 3 hours. The trade-off is operational complexity. You must account for the continuous thermal energy required for heating and the labor needed to balance those sensitive stabilizers. While Thiourea and Thiosulfate deliver specialized results, they require intense process monitoring and the management of harsh, high-maintenance environments. If the goal is maximizing the value of the final product, halogens and their compounds offer a high-purity alternative. Halogens require significant pre-processing. Ore is roasted at 800 degrees Celsius to remove 97% of the sulfur before an acidic chlorine wash. This produces gold with over 99% purity directly from the chlorinated solution, effectively bypassing the need for a secondary refinery. Naturally, the barrier to entry is the massive upfront capital required to build and maintain industrial roasting infrastructure. For plants prioritizing operational continuity, commercial compounds like JIN CHAN present a different strategy. JIN CHAN has the simplest requirements of the group. It dissolves in room temperature water and uses basic lime to reach a pH of 11.5, conditions very similar to standard cyanide circuits. Its primary value is compatibility. JIN CHAN is a 100% drop-in replacement, requiring no changes to your existing pumps, tanks, or recovery equipment. This makes it highly effective for massive operations, including CIP, CIL, and heap leaching, where the cost of retooling would be prohibitive. The trade-off here is a reliance on a proprietary commercial supply chain rather than the open market for industrial chemicals. While halogens offer purity through new roasting infrastructure, commercial options like JIN CHAN prioritize immediate compatibility with your existing plant setup. The optimal chemical choice for your operation is dictated by your plant's current infrastructure and the specific mineralogy of your ore. This decision framework starts with a fundamental question: do you have an existing CIP or CIL leaching circuit? If your objective is to minimize capital expenditure and avoid retooling your current equipment, JIN CHAN is the most direct path forward. If you are a refractory specialist dealing with copper-heavy ores that standard methods can't process, the energy costs of thiosulfate are a justified expense. For the purity optimizer who has the capital to invest in 800-degree roasting, halogens allow you to bypass the refinery and move straight to high-purity yield. Finally, if you are a scavenger processing acidic residues or anode mud at high speed, Thiourea is the choice, provided you can manage the accelerated equipment wear. Transitioning away from cyanide requires a rigorous audit of your equipment and ore profile before you commit to a single barrel of alternatives.